Students, I hope you're having a great weekend. As you can see here, I've got Mr. Walker with me and Miss Crawford. And we're going to do a little introduction to section 10.4. 10.4 is multiplying binomials. So in your notes, let's get that down first. Section 10.4, multiplying binomials. We spent some time talking about what it means to be a monomial, a binomial, a trinomial, and all these different types of polynomials. So now let's apply multiplying binomials together. The nice thing with this section is it's really the distributive property beefed up, or the distributive property kind of on steroids, right? That's how I like to say it. And Mr. Walker, I apologize, my handwriting's not quite as neat as yours. Might have to get you up here too. So what I want to do with the students is actually walk us through a couple examples of just the distributive property from the beginning. So the first one we have is 3x squared multiplied to 2x minus 5. 3x squared times 2x minus 5. Anybody have some thoughts here? Yes, Ms. Crawford.
So when I look at that, I remember that I'm going to multiply the coefficients first. So I'm going to go 3 times 2, which is 6. And then the variable part would be x squared times x, or x to the first power, and that would be x cubed.
Very good.
Thank you.
Very good. So we have 6x cubed with our first terms here. And then we also have to do that 3x squared times the negative 5.
I think Mr. Walker should do that part.
You can take that one?
The way I remember is I just did the whole thing, and I did 3x squared times negative 5. I looked at it as a negative 5 instead of subtracting 5.
Very good.
So 3x squared times negative 5 is a positive times a negative. I think it makes a plus and minus. I think it's a negative.
It's going to be negative, you got it.
So then it would be negative 3 times 5 is 15, and then we have x squared.
X squared. And because these are not like terms, remember that from 7th grade Algebra A? They're not like terms, we can't combine these with subtraction. So that's going to be actually my final answer, or my product. Moving on to this next one, we have a couple of steps here at once. We have a times the quantity of a minus 5, and then plus 3 multiplied to the quantity of a minus 5. Again, let's take a look at that distributive property.
Yeah, it looks like we're doing the distributive property 2 times.
It is the distributive property 2 times. Way to point that out, Miss Crawford.
Yeah,
wow.
Gotcha.
So we have this a times a.
A squared.
A squared, we got it. And then a times a negative 5, or the minus 5, however we would look at it, potato, potato, right? Gives us a negative 5a.
Could I do negative a5? Would that be the same thing?
And then negative a times 5, you could write it that way. It's not technically the best mathematically appropriate way to write that.
I remember in Algebra A, Ms. Crawford really got on us that the coefficient has to come first.
Okay.
Exactly.
Yeah.
We want that coefficient coming before the variable, and then exponents can come after the variable.
Okay.
Okay. Moving on to this next one. Great question, Mr. Walker. We have 3 times a, which is a positive 3a. And then this positive 3 times the negative 5 give us negative 15. And I'm done, right? No?
I noticed something right away.
What's that?
I noticed I can combine like terms, and I remember this from Algebra A. These are like.
They are.
Oh, there are 2 A's there.
There's 2 A's. Let's merge them.
So when they merge, when we bring those A's together, what's our final answer going to be?
A squared minus 2A.
2A.
Minus 15.
Minus 15. Very good. Very good. All right. Here we now have no like terms, nothing else to simplify or bring together. All right. This problem, we had the a being multiplied to a minus 5, and we had the 3 being multiplied to a minus 5. There's another way of writing that, another way that we could represent having
because
both the a and positive 3.
Same.
Exactly. Thank you for pointing that out, because both of these are a minus 5. Do you know what's the other way we could write it?
Well, write down a minus 5.
All right, a minus 5 is definitely one of them, so we want to get that down.
So if we do that, what's
That's
left?
one of our factors. What else do we have?
A left, and there's a 3 left.
Yeah.
Like, could you do this?
We have the a and the plus 3 as other factors of this expression. A was being multiplied to a minus 5, and the 3 was being multiplied. So I have one factor of a minus 5, another factor of a plus 3,
Cool.
and now we're looking at actually multiplying two binomials.
Would that get me the same answer?
Let's look.
Okay.
Great question. Let's check it out.
All right.
So if we look at this, again, I know you were probably not too comfortable with seeing two things in parentheses being multiplied, but let's just take it step by step. What it's telling us is everything in this parentheses has to get multiplied to everything in this parentheses. So we can take our a and multiply it to this a to get us
A
squared.
squared.
a squared, very good, two factors of a. And then this a needs to also get multiplied to this 3.
Yeah.
So that's a 3a, very good. Not a3, but 3a, that coefficient comes first. Now, we've taken care of this a, it's been multiplied to both of these terms. What about the negative 5?
I bet we could do something like take this -5 and go like this.
You're exactly right. The negative 5 needs to be multiplied to both, so we have a negative 5a, and then the negative 5 times the 3 gives us a minus 15.
It's almost exactly the same.
It is.
Yeah, they just switched.
Hey, isn't that the commutative property where the order doesn't matter?
And
Yeah.
just switch that order
All
around.
right.
So now if we do again combine these like terms of the negative 5a and the positive 3a, what's our final answer going to give us?
A squared.
The same
A squared
That is amazing.
Wow.
Minus 2a,
minus 2a.
minus 15.
Minus
And it
15.
saves you time with like what you write down.
Perfect. So
Awesome.
this is what we're going to be talking a lot about Monday, Tuesday, and Wednesday, multiplying these binomials. Hopefully you get to see how it comes from the distributive property. It's that extension of the distributive property.
Can maybe we do something like this over the weekend just to try it?
Yeah, I like that one there. This is a plus 2 times the quantity of a minus 4. Let's try to work on that in your notes over the weekend. If you have some questions, you can stop in Mr. Walker's room, Miss Crawford's room, or my room Monday morning and see what we've got.
I'm going to add another one too.
Ooh, another one as well.
Negatives.
Another one
Okay.
as well. A minus 2
See negatives.
times a minus 6.
Is it subtraction?
I think so.
Okay.
Yeah.
We'll
All
see
right.
what works out here. Okay, that's all we have for you guys. Let's thank Miss Crawford and Mr. Walker for being our special guests. And math out.